happen if I plot the function and its inverse on the same coordinate plane? What relationship should you see? Uh-oh. Did we not learn this last year? Wow, I'm surprised. This is just something that I really drill into my kids, so I'm kind of surprised. Maybe it will sound familiar. Yes, a reflection over y equals x. So before I can get there, how do you guys go about typing in the cubed root of x minus 1 into your calculator? You do the math? Okay. Sometimes, I mean, my calculator didn't used to have a cubed root button when I was in high school. At least I didn't know about it. So I used to always write that as x minus 1 to the 1/3 power, which is the same thing. You all know that, right? But we do have a cubed root option nowadays with our advanced technology. Okay, so if I look at this, we should see that these two functions are a reflection of each other over the line y equals x. And if you need to see it, you can also graph the line y equals x just to kind of make that your line of symmetry. Yes? Everybody see that? Okay. And all things x's and y's did switch, and that's the other important thing to notice. So like this one has a y-intercept of 1, this other one's going to have an x-intercept of 1. Whereas this had an x-intercept of -1, so this one's y-intercept is -1. If something has the point, and you can take those same points and do this, if this has the point 0, 1, then flip-flop those, this one's going to have 1, 0. So all things x's and y's are flipped. Okay? Another inverse. So writing an inverse, x equals y squared, square root of both sides. So y equals, this is where we do need that plus or minus root x. So the inverse of x equals plus or minus root x. So what's different about this one? Say it again. This is not a function, correct? Because the original was a function, that's just a parabola. But this one, in order to type that into your calculator only graphs functions, as long as you're working on the 84. It only graphs things that are functions. And so you're not really allowed to type this in all in one shot because it's not a function in its entirety. In order to get our calculator to see what we're doing, we actually have to plug in the square root of x and as a second function the square root of, or the negative square root of x. So in isolation, that's a function, and in isolation, that's a function. But in its entirety, which is what the inverse is, these two together do not make a function because it fails the vertical line test, yes? Okay. What is it about the original function that would tell us that the inverse was going to fail the vertical line test? So if I go back to the original and look at just the parent graph of x squared, what feature about this tells us that its inverse will not be a function? Because its inverse is going to fail the vertical line test. Did you do this last year? If the original function fails the horizontal line test, right? Think about switching the x's and y's. There's something called the horizontal line test on a function. And it's used to determine whether or not the inverse will be a function. And if the original fails the horizontal line test, even though it passes the vertical, the original is still a function, so we're good there. But if the original fails the horizontal, then we know its inverse is going to fail the vertical and therefore not be a function. Okay? Have you ever heard of that, horizontal line test? No, okay? So I wrote about it here. If a function passes this test, then its inverse will also be a function. If that's the case, then it's a more special type of function. It's called a one-to-one function. Does that sound familiar? Never heard of that? You have. Yeah, I teach it to my algebra too, so not a critical thing for the Regents, obviously, otherwise you would have seen that with Mrs. Ziggy, but it could come up. So knowing what a one-to-one function is. A one-to-one function essentially is something that is a function, obviously, but whose inverse will also be a function. Okay? So a function whose inverse is also a function. And the quick test for that is passes vertical line test. Obviously, that's what makes it a function to begin with. And a horizontal line test. So if you're looking at a table of values, what happens that would make something not a function? What do you see in a table of values that lets you know something is not a function? Right, a repeating x value with different y values. That tells you from a table that it's not a function. So what from the table would tell you that it's not a one-to-one function? Correct. If the y's are repeating. Yes? So if you're looking at a table, the third way to notice a one-to-one function is that there's no repeating x's. Obviously, that makes it a function. And no repeating y's. That's what makes it a one-to-one function. Good? So I guess that's a little bit of a new concept for you. Sketching a graph of an inverse is getting back to this point about seeing reflections across the line y equals x. So, and also flip-flopping those x's and y's. So if here's our original function and -3, -2 is a point on that function, then Kendall, what would be a point, the corresponding point on the inverse? -2 what? Yep, -2, -1, 2, 3. Good. What's going to happen in -1, 0, Stephanie? 0, -1. And 6, 2 becomes what, Maria? 2, 6. And then you see the symmetry. Okay? And our last one. We're finding the inverse of this function only on a certain interval. So let's first sketch a graph of this. This parent graph is a parabola, and how has it been moved? How has it been transformed? What's the -1 do to it? Come on. What did you say, Taylor? Shift down 1. So here's -1. And there is our function. But they only want us to write the inverse if x is greater than or equal to 0. So we really don't want this piece. Why would that be, do you think? Why do they want the original function to only be this piece and not the whole thing? Yeah? Correct, because if they had this other piece, then this would fail the horizontal line test and the inverse wouldn't be a function. So this is their way of maintaining that we're gonna make this a one-to-one situation. Okay? So when we go to write our inverse, and I know you can all kind of hopefully whip that together real fast. We would typically have that plus or minus symbol because we just took the square root of both sides. But here's the thing with the flipping of the x's and the y's. If our original function says that x has to be greater than or equal to 0, then the inverse function is going to say that y has to be greater than or equal to 0, right? Because you're flip-flopping the domain and range. So if this one has a domain greater than or equal to 0, then this one's range has to be greater than or equal to 0. So what don't we need? The negative. Because we don't want y to be negative. So our inverse function is only the positive square root of x plus 1. And we don't have to limit our y. We don't have to really say that because it's already going to happen. We kind of manually took that negative option away. We don't need to further say that this always has to be greater than or equal to 0. It will be on its own. Does that make sense? Okay, so if you see a limited domain situation, understand how that's going to limit the range. So now if I were to just graph this piece, let's see, 0, -1 would be -1, 0. The inverse piece would look like this. So f inverse versus f of x. And you only get that one side of it as opposed to a sideways parabola. Good? Okay, so I am done. Oh my word.